Hi, welcome to the mathematics in my channel. Today we are going to discuss about interesting point in mathematics, negative factorial. Okay, can we define minus 1/2 factorial? Well, first we know if we take n factorial is equal to gamma of n plus 1, and also we can write this is by using pi function, so pi of n, and here factorial defined for positive integers. Okay, now today we are going to find the minus 1/2 factorial. Okay, we know pi function, so pi of x is equal to integral from 0 to infinity t to the x times e to the minus t dt. Okay, now we can plug in here. So if we plug in minus 1/2, here we know pi of n is equal to n factorial, so we can write minus 1/2 factorial is equal to integral from 0 to infinity t to the minus 1/2 times e to the minus t dt. Okay, now here we can write 0 to infinity. Now here e to the minus t, here negative power, so e to the minus t, and here 1 over t to the 1/2, so square root of t, so we can write e to the minus t over square root of t times dt. Okay, now what can we do? How to evaluate this integral? Okay, we can use substituting method. So if we take u is equal to square root of t, now u square is equal to t and differentiate, so 2 times u du is equal to dt, and limit when t approaches to 0, u also approaches to 0, and upper limit when t approaches to infinity, so u also approaches to infinity. So we can write this is equal to 0 to infinity. Now e to the minus t sorry, e to the minus t, so we know t is equal to u square, so we can write here e to the minus u square over square root of t. We know square root of t is equal to u, so u times now dt is equal to 2 times u du. Okay, now this u get cancelled and 2 is a constant, so we can write 0 to infinity, here 2 times e to the minus u square du. Okay, now this is familiar with us because Gaussian integral, half of Gaussian integral, we are going to evaluate this integral. Okay, I write here this place, so 0 to infinity, and I will take this is equal to I, 0 to infinity e to the minus u square times du. Today in this video I am going to evaluate this integral by using substituting method. Okay, now if we take here I, so I am going to take I square, so we can write here this is equal to 0 to infinity e to the minus u square du times again 0 to infinity. Now I change the variable because definite integral independent of the variable, so we can write this is equal to e to the minus y square dy. Okay, now Next step, we can write I square is equal to integral from 0 to infinity, again 0 to infinity, e to the, here minus u square, here minus y square, so we can write minus u square minus y square, here du, and here dy. Now we can use substituting method. So if we take I write this place here, t is equal to x over y, so sorry, here u over y, we take u, so we can write u is equal to y times t, and du is equal to y times dt. Now the limit when u approaches to 0, t also approaches to 0, and upper limit u approaches to infinity, t approaches to also infinity. Okay, now here we can plug in our limit, also 0 to infinity. Now here integral from 0 to infinity, here e to the, now u is equal to y times t, so we can write here minus y square t square, here y square, and here du is equal to y times dt, so y times dt, here dy. Okay, then we can write 0 to infinity, again 0 to infinity, here e to the minus y square is a common factor, so minus y square times t square plus 1, and then y dy dt. Okay, now integral of this function. So we know differentiation and integration are inverse process. So if we differentiate this e to the this function, and derivative of, according to chain rule, derivative of this function, so minus 2 times y times t square plus 1, and y get cancelled, so we can write this is equal to 0 to infinity e to the minus y square times t square plus 1 over then now this y get cancelled, so derivative, so minus 2 times t square plus 1, and now limit y approaches to 0, so sorry, y is equal to 0 to y is equal to infinity, and here dt. Okay, sorry. Okay, now our integral here I square is equal to, now here we know 0 to infinity, sorry, 0 to infinity, and now if we plug in infinity here, e to the minus infinity square, so we know this is going to 0, and if we plug in 0, so minus this minus, so plus e to the 0, so 1, so we can write here this is integral of this function, so this is equal to 1 over 2 times t square plus 1 here dt. Okay, now here 1 over 2 is a common factor and a constant, so we can write outside of the integral, so 0 to infinity 1 over t square plus 1 dt, And now this is very easy because we know 1 over t square plus 1 is equal to arctan, so we can write 1 half inverse tan of t 0 to infinity, so we can write 1 half. Now if we plug in infinity, so tan inverse infinity, so we know 5 over 2, and if we plug in 0, this is 0. Okay, now I square is equal to pi over 4, so I is equal to square root of pi over 2. Okay, now interesting. Now our next part, we started by minus 1 half factorial, and we know this is equal to 2 times 0 to infinity e to the minus u square du, and now we evaluated this integral. This is equal to square root of 5 over 2. Now here this 2 get cancelled, and the square root of pi. Okay, this is interesting. Minus 1 half factorial is equal to square root of pi. Okay, if you like this video, please subscribe this channel. Thank you for watching.